I'm not pleased because I just recorded this entire video and then I did not have my screen showing. Hello, welcome to the last lecture of this semester of Algebra 2. Today we're going to talk about vertex form. We've been talking about zeros and such a lot, but now we're going to go over vertex and vertex form. We're going to understand the vertex better and know how to find the vertex and stuff. That'll be great. Okay, so the vertex is the point on the tip of the parabola, and it's a coordinate point. So it's going to be something like 515 or something. So yeah, it's important to know that as coordinate points. Some new definitions is minimum and maximum. The vertex is always either a minimum or a maximum. And when your equation's going like up in both directions, then we would call the vertex, you could call it a minimum. And when it goes down in both directions, you would call it a maximum. It's a minimum here because it's on the bottom, the smallest. Here it's on the top, so it's the biggest. Also, if you remember, if you have an equation like 2x, that's like a positive x squared, that's when you get this. When it's a negative, that's when you get that. Just a little refresher. How do we find our vertex, though? So there's this nifty little equation that I don't really have time to explain, like how you get to it. But when you have your equation in standard form, you can find your x-coordinate of your vertex by putting this. So you put your b here, you put your a there. B and your a are just those, the coefficients, the numbers that are just, these are just placeholders. So you're basically going to plug two numbers into here, solve this to get your x-coordinate of your vertex. So then once you have your x-coordinate, how do you find your y-coordinate? Well, you do that by, like with any x-coordinate, you just plug it back into your equation to get your y. And then you both have your x and your y of your vertex, so you know exactly where your vertex is on the graph. Once again, use this equation to get your x, then plug it back in to get your y. So that's how to find the vertex. Now let's talk about vertex form. So vertex form looks something like this. There's three numbers that are going to be here. Your h is the x-coordinate of your vertex, and the k is the y-coordinate. And the a is just going to be the same a that's here. So that's how we get these three numbers for vertex form. I don't have time to go over why, when you have this vertex, you can put it into your equation into a form like this, but it works. You can distribute this all out again, and this works. And when you already have an equation in vertex form, it's very easy to find what your vertex is. You just take this number and this number. You have to switch the sign of the number that's here, like if it's x plus 3, your h is negative 3, it's not 3. Yeah, it also takes some effort to put your equation in vertex form. And what exactly do you have to do to put it into vertex form? So you have to find your vertex, and once again you do that by using this equation to get your x, and then you plug that back into your equation, into this equation to get your y. And that's also you'll call your h and your k. And then you already also know your a. A is this number. So to put your thing in vertex form, you just put those three numbers into here. You just replace the a with this a, replace the h with the x-coordinate of your vertex, the k with the y-coordinate of your vertex. So that's how you convert your stuff into vertex form. You don't have to factor anything. You just follow this process. If you already have something in vertex form, it tells you what your vertex is. This and this is your vertex. And to convert it back into standard form, you can just distribute again. I'll do some examples of that, but you basically just have to distribute, combine like terms, and you get back to standard. So, yeah. Next, I have to cut these videos up because of time. But I'm now going to do examples on the next video if you want to watch examples. If not, just try the math.